Okay, I'm back. Now, in order to understand this picture, we need to go back again to Bowen's reaction series. So if we go back to here, you notice that if you had the mineral olivine and you also had the calcium-rich plagioclase feldspar, then you would end up with an ultramafic rock. And you had to go kind of sideways to get to that particular kind of rock. Well, in this picture here, we're going up and down. So let's look at the ultramafic rock. And so you can see that it is composed mainly of the mineral olivine with a little bit of pyroxene thrown in. So the yellow part is telling you the percent of olivine that's contained in that particular kind of rock. And you see that it's mostly yellow in that column, which means that the majority of the ultramafic rocks are only composed of olivine. But then they also have some pyroxene. Another name for pyroxene is augite. And so this is going to make up ultramafic rocks that are going to make up the mantle of the earth. And you can see that there are two kinds. You have comatite, which is a very rare kind of igneous rock, and then you have periodotite, which is the much more common type of igneous rock that you're going to find in the mantle. Now let's go to mafic. So if you recall, according to Bowen's reaction series, what happens is that as olivine cools off, it tends to fall apart and then is reconstructed as pyroxene. So if you've got a rock that is composed of pyroxene, and now look above it, so you notice there's that calcium-rich plagioclase feldspar. So that the mafic rocks contain a lot of calcium-rich plagioclase feldspar and a lot of pyroxene, and you can see a little bit of amphibole is thrown in there for good measure. And then that is going to make the igneous rocks scoria, basalt, and gabbro. Okay, then you're going to have the intermediate rocks that are going to be composed. Now, at this point, it's kind of half and half, sodium-rich plagioclase feldspar and calcium-rich plagioclase feldspar. So it's kind of half and half. But you can see that it also has a lot of amphibole, and it's got now a little bit of pyroxene in it. And so this is going to make up the igneous rocks andesite and diorite. Okay, then by the time that we get over to those felsic rocks, you see that they contain a lot of quartz, a lot of potassium feldspar, some sodium plagioclase feldspar, and then you also have some mica and some biotite in them. And then they make, you can see pumice and obsidian and rhyolite and then granite. So that those are the rocks that have those particular minerals in them. So then the question is, what's the difference, let's say, between rhyolite and granite? So rhyolite and granite, they are identical in what minerals that are in them. So the difference is the size of the crystals. So do you remember that phaneritic means you can see the crystals in it, and then that meant it formed under the ground. So deep underground is where you get granite. On the other hand, aphanitic means you don't see the crystals, and that means it formed near the surface or on the surface of the earth. So that's going to be the rhyolite. So that's the difference between those two. So let's look at andesite and diorite. So what's the difference between them? Well, they're both made of the same minerals. So the difference is diorite formed where? It formed under the ground because it's got large crystals, and the andesite formed at the surface of the Earth or near the surface of the Earth because it's got that aphanitic texture. And then I will let you do the basalt and the gabbro. Okay, so let's go talk about each individual igneous rock. And so let's do that in our next segment.